We'll be learning about 16 more AWS EC2 strategies, and this is part 2. I'm Chris, Cloud Architect and founder of systemsarchitect.io and codeguides.io. I'll be guiding you through this journey. Part 1 covered the biggest architectural decisions on EC2. This part is different. These 16 strategies are the configuration review. It is the pass you make over instances that are already running. Almost every EC2 incident traces back to a setting nobody checked, not a decision nobody made, a key pair nobody can find. A security group opened for a debugging session 2 years ago, an alarm that was never wired to anyone. This video walks through 16 checks covering instance type, access, network controls, storage, monitoring, lifecycle, and cost tracking. 16 AWS EC2 strategies, Part 2. 1. Match the instance type to the workload. 2. Manage key pairs for secure SSH access. 3. Configure security groups correctly. 4. Review network ACL configurations. 5. Assign elastic IP addresses when needed. 6. Check auto-scaling group configuration. 7. Verify EBS volume attachments. 8. Scope instance IAM roles correctly. 9. Set up CloudWatch monitoring and alarms. 10. Review instance lifecycle settings. 11. Keep AMIs current and standardized. 12. Take regular EBS snapshots. 13. Use placement groups for network performance. 14. Apply cost allocation tags. 15. Set instance shutdown behavior. 16. Configure user data scripts. 1. Match the instance type to the workload. Verify the type still fits what the instance actually does. The family letter tells you the intent. M is balanced, C is compute, R is memory, I is local storage, G and P are GPU. A memory-bound app on a compute instance will thrash while its CPU sits idle. Check the generation 2 because older families cost more for less. Test whether the workload runs on Graviton, where ARM software often gets better price performance. 2. Manage key pairs for secure SSH access. AWS keeps only the public half of a key pair. The private key is downloaded exactly once, and there is no recovery path if you lose it. Confirm you know where each production key lives and who holds it. The stronger move is to stop depending on key pairs at all. Session Manager gives you shell access through IAM. No inbound port 22 and no bastion host. EC2 Instance Connect is a middle option that pushes a key valid for about 60 seconds. 3. Configure security groups correctly. This is the highest value check on the list. Security groups are stateful and allow only, so return traffic comes back automatically. Start by hunting for anything open to the whole internet on a management port. SSH on port 22 or RDP on port 3389 open to the world is a finding, not a configuration. Reference other security groups as sources instead of raw address ranges. The rule then keeps describing your intent as instances are replaced. 4. Review network ACL configurations. Network ACLs sit at the subnet boundary, not the instance. Unlike security groups, they are stateless. Allowing traffic in does not allow the response back out. Return traffic needs its own rule on the ephemeral port range. Forgetting that is the most common cause of a connection that opens and then hangs. ACLs do support explicit deny, which makes them right for a subnet-wide block. Rules run in ascending number order, and the first match wins. 5. Assign elastic IP addresses when needed. An elastic IP survives a stop and start, which a default public IP does not. Confirm one is attached where a partner allow lists you or a DNS record cannot change quickly. Then confirm you have not attached one where it is not needed. Every public IP version 4 address now bills hourly, attached or idle. Every audit the unassociated list regularly. Most architectures need none. Private subnets, a load balancer, a NAT gateway, and Route 53. Part 6. Check auto-scaling group configuration. What does a health check actually check? A group set to EC2 health checks only notices when an instance stops running. An application that has hung while the instance stays up keeps taking traffic. Switching to ELB health checks lets the load balancers probe drive replacement. Set the minimum size for surviving a zone failure, not for your idle load. Confirm the group truly spans multiple zones, not just on paper. This video is a condensed version of what we have on systemsarchitect.io. See the full section there. Also make sure to like the video and subscribe to the channel for more, and check the video notes for links. 7. Verify EBS volume attachments. Attached is not the same as mounted. The failure people hit is a volume missing from the FS tab file, so it vanishes on the next reboot. Use the device UUID rather than the device name, and add the no-fail option. GP3 lets you provision IOPS and throughput independently of capacity. Check the delete on termination flag deliberately, since it defaults to true on the root volume and false on the others. 8. Scope instance IAM roles correctly. A role gives applications temporary rotating credentials. Verify no instance is still carrying static keys in a file or an environment variable. Those keys leak because they end up in AMIs, in source control, and in logs. A web server reading one bucket should name that bucket, not take blanket S3 access. Use separate roles per tier so a front-end compromise cannot reach the database. Confirm IMDS version 2 is required, which closes the request forgery path used to steal credentials. 9. Set up CloudWatch monitoring and alarms. Why install an agent? Memory and file system space are not collected by default because the hypervisor cannot see inside the guest. The CloudWatch agent closes that gap. An alarm nobody receives is not monitoring, so check each one has an action and reaches a real channel. Include the status check metrics so a failing instance triggers recovery automatically. Enable 1-minute detailed monitoring in production, since 5 minutes is too coarse for auto-scaling. 10. Review instance lifecycle settings. Termination protection blocks termination through the console, CLI, or API. Turn it on for stateful and long-lived servers. It does not stop an auto-scaling group or a spot interruption, so it belongs on pets rather than cattle. Hibernation writes memory to the encrypted root volume, so processes and warm caches come back intact. It must be enabled at launch and cannot be added later. 11. Keep AMIs current and standardized. A stale image means every new instance starts life behind on patches. Verify images are rebuilt on a cadence, not whenever someone remembers. EC2 Image Builder automates the whole pipeline. It covers hardening, testing, and distribution. Standardize on a few golden images so instances behave the same way. Hold the current AMI identifier in parameter store, so updating one parameter rolls the change everywhere. 12. Take regular EBS snapshots. Snapshots are incremental, so only changed blocks are stored. Verify the schedule matches how much data you can afford to lose. Why automate it? Automate it with Data Lifecycle Manager or AWS Backup, not a cron job on a server. AWS Backup adds vault lock and cross-account copies, which is what saves you in an account compromise. An untested backup is a hypothesis, not a recovery plan. 13. Use placement groups for network performance. A placement group controls how EC2 physically positions your instances. Cluster packs them into one zone for the lowest latency, which high-performance computing and trading systems need. Spread puts each instance on distinct hardware, so one failure cannot take two down. Partition splits the group into separate failure domains for Cassandra, Kafka, and HDFS. A cluster group concentrates all your risk in one zone. 14. Apply cost allocation tags. Tags turn one large compute charge into a bill you can assign to a team. Agree on a small mandatory set: owner, environment, application, and cost center. Then activate those keys as cost allocation tags in the billing console. Activation is the step people miss. An unactivated tag never appears as a dimension in Cost Explorer. Enforce them with AWS config rules and tag policies, and confirm they propagate from launch templates. 15. Set instance shutdown behavior. This decides what happens when the operating system itself issues a shutdown. The two values are stop or terminate, and the default is stop. Terminate destroys the instance, and the root volume goes with it. Verify it is set to stop on anything stateful or long-lived. It is independent of termination protection, which only blocks the API and the console. Check both together, since the combination decides whether an instance can destroy itself. 16. Configure user data scripts. User data is a script the instance runs on first boot. Verify it is idempotent, so rerunning it does not break a working configuration. Confirm it exits non-zero on failure rather than continuing past a broken step. Never put secrets in user data. It is readable from the instance metadata service. Anyone with described permissions can see it. Pull credentials from Secrets Manager at runtime using the instance role instead. In summary, Part 2 is the review pass rather than the design pass. Access and network controls come first. Key pairs, security groups, and network ACLs are where a misconfiguration becomes an incident. Next comes runtime configuration, instance type, volumes, auto-scaling, and IAM roles. Those drift quietly as a system evolves. Then the operational safety net of monitoring, snapshots, AMEs, and lifecycle protections. That net only helps if you verified it before you needed it. Cost allocation tags and shutdown behavior close the loop. Run this list against a running fleet rather than reading it once, and pair it with Part 1 for the full picture. Thanks for watching and listening to this, and subscribe to the channel. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.